Guys, welcome to thermodynamics online tutorials. On today's episode, we'll be discussing the more problem-solving techniques on thermodynamics. Welcome back. So now the question we have before us says, water vapor initially at 3 bar and 160 degrees Celsius expands to 1.0 bar in a piston cylinder assembly according to a PV raised to power 1.2 equal constant. So now our problem now is to determine the specific volume at the final state. Remember the word there, specific volume. It carries a lot of weight, if I must say, in meter cube per kilogram, and the work developed in kilojoules per kilogram. So now we are meant to sketch the process on a carefully labeled TV or PV diagram. So now let us solve the question. Now for this case, we're going to be sketching it on a TV diagram. So now sketching it on a TV diagram becomes, this is a TV diagram. Remember our dome on the TV diagram. This is our process 1. This is our process 2. So we go from process 1 to 2 to 3 and 4. So we have our P1 to be what? 3 bars, and our P2 to be 1.0 bar. Our V1 to be X and our V2 to be Y. What we need to get first is our V1, then our V2. We would have made some assumption, but this question does not carry much information for that. So now let us get our V2. Now we first need to get our V1 first. And now to get our V1, we go to the property table. So now you go to the property table of pressure. You go to pressure of 3 bars. You check pressure 3 bar, and because it's the first column, the pressure is the first column, that is the pressure table. You go to 3 bar. Now are you in 3 bar? With your pressure table, I would suggest property table, I would suggest you go right there now. Are you in 3 bar now? So are you at 3 bar? So you check, you go down now, you trace down to temperature of 160 degrees Celsius. You find that it is not oil, that is not up to 160 degrees Celsius. It is lesser. So since it's lesser, you go to the superheated table. So now we have our pressure to be in 3 bar, but we need it to be in megapascal. So, but we know that 1 bar is equal to 1 times 10 to the power 5 pascal. We want to put it in a megapascal. We have it to be 3 bar times this. So this becomes 3 becomes a pascal. Now to get it in megapascal, we times it times 10 raised to the power what? With minus 5. And that gives us 0.3 megapascal. So now after you've gone to 0.2 megapascal, you now go down to the 0.2 megapascal coulomb of the superheated table. Now you check for the temperature of 160 degrees. So now you find our V there, which is our V1, to be 0.651 meter cube per kilogram. So now to get our V2, we use this formula P1 V1 N equals P2 V2 N, making V2 subject of formula. Let me clean this up. Making V2 subject of formula, we have P1 P2 1 over N multiplied by V1, which gives us 3 over 1 raised to power 1 over 2 times 0.651. Our V2 becomes 1.626 meter cube per kilograms. So we've got our V2 already. Now let us get our work. That's the second task we are given to get our work. So now our work becomes work equal P2 V2 minus P1 V1 over 1 minus N. And our P2 become 1 times 1.626 minus P2, which is 3, 0. times 0.651 over 1 minus N. So now after we've calculated our answer is going to be in joules, but we need to get our answer in a kilojoules. So we multiply times 10 raised to power 2. So after we multiply all this multiply by 10 raised to the power 2. So when we multiply 10 raised to the power 2, our answer should be 163.5 kilojoule per kilograms. So now with this being said, we'll be drawing the curtain here, and we're going to be dropping another video also on thermodynamics. So, and after thermodynamics, we'll be dropping a video on mass 207, which is advanced mathematics part 7. So at this rate, I'll be dropping a comprehension for you to practice on your own, and also you can drop your answer on the comment section below. Please don't forget to subscribe and like our video, and also share to help the channel. God bless you. Bye bye.